Okay, so we're going to talk about modern data management. My challenge today is going to be to reduce what is a 30-minute presentation to 15. Yours is going to be to hang around until the end until you get a prize. The more you sit, the more raffle tickets you'll get. So, my name is Pedro Pires. Actually, this is my married name. Pires is my single name, by the way. I'm from the process and data management team at Keysight. And we're going to cover a couple of details, right? So we're going to talk about why managing data is a challenge today. We're going to talk about what our solution does to address those requirements. We're going to go about a few case studies, talk about best practices and gotchas, and some closing remarks and a call to action, okay? So why is data a bottleneck today? First of all, we see that projects are growing in complexity. So they grow in terms of size, in terms of number of files, in terms of the technologies and techniques that are being folded into the mix. This creates additional challenge when you're talking about collaboration. So we're talking about mixing all these different teams together. These teams can be scattered across the globe. And of course, when we talk about collaboration, we talk about opening avenues for your data to be shared, which creates other challenges like how do you share your data securely? How do you keep track of which data was shared by whom? There's in fact a lot of cost that comes with mismanaging your data. We've done a survey a while ago and we found out that companies face 63% productivity loss just by having data mismanaged. 30 to 40% is basically time spent looking for stuff. Then you frequently not find the stuff that you are looking for and you spend 20% more just fixing the errors that you made. So if you just do back of the envelope calculation, like a team of 10 engineers, each costing $255K to the company, we're talking about $1.8 million that is lost. Tool sets are growing in complexity. Over 2/3 of your engineers have to work with 6 or more tools. This will increase, the manual tasks that you have to do, the time that you have correlating data, and data that is being transferred using non-standard ways like paper notes. If you think about all these tools coming together and the fact that users have to use manual workflows to transfer the data from one tool to the other, each time that you take your data from one tool to transfer it to the next, you create opportunities so that your data isn't safe. In fact, more than 74% of the people that answered our survey state that spreadsheets are the #1 data format to transfer knowledge around. And 72% regularly use paper notes or emails. It's of no surprise that more than 50% of the executives see data security as a top concern. And just so you know, 1 in every 4 global cyber attacks happens to manufacturing companies, and we're talking about on average $5 million that are wasted into this. So basically your flow is breaking up because there's a ton of data, there's a lot of tools that are brought into the mix, there are knowledge silos and disconnected and manual workflows. This is essentially a data lifecycle issue, okay? So data management is mission critical for any modern project. And a modern data management infrastructure gives you access to features that operate at 2 levels. On the immediate level, it's the team collaboration, version storage, version control, collaborative features, the ability to mirror your data across different geographies. But as complexity scales, you need to tap into organizational level collaboration. So we're talking about frictionless data access. We're talking about sharing your data across your entire enterprise, which then creates other necessities like the ability to do so securely, to keep track of your data is utilized. So you want to build this organizational memory, and this is where SOS comes into place, right? SOS gives you a platform that has centralized data and IP management. So this allows you to do management at the individual file level, but then when you abstract into IPs, into systems, into complete projects, it also does that. It promotes reuse-driven data management. Every asset that you manage in SOS can be reused in another project, and when you do it like that, you don't lose track of the source of your data, so all that digital thread is preserved. It offers the richest portfolio of integrations with EDA tools in the industry, so you don't have to step out of the tool that you're already working to manage your data. And it has a plethora of features that optimize your resources. So we're talking about eliminating duplication of data, doing sharing of data in an high-performance way, and it is very simple to use. So Keysight SOS is not just a data management tool, it's actually an organizational memory engine. we don't really care about which data you are working on. We manage all types of data into the same database, and we also don't care about the size of your organization. If you're a startup that is just looking for best practices and a formal way to scale up, or if you're a mature company that needs a robust, reliable data infrastructure, SOS is for you. So SOS is really for anyone that is struggling with data chaos, traceability, or collaboration. Now, looking at a case study for data lifecycle management for AI ML, because as you can see, AI is the talk of the town. So here we are talking about a team that is 10 engineers, one non-engineer, a manager, and they are working across 3 data centers. So 1 data center, 1 development area, and 1 production area. Projects they are working on 1 to 2 projects per year. Each project is 6 months to 1 year, and their application is retrieval augmented generation. Their data is multimodal. Their data sets are relatively small, 10 to 20K samples per data set, and we're talking about 20 to 30 data sets on the mix. Their original pipeline looked a little bit like this, right? So let's explain this a little bit. They had the raw data that was being processed by scrapers and parsers. They were creating a data set out of it, which they were pushing into a min.io service. And then when they wanted to work on the data, they would download the data, extract the embeddings, copy the embeddings over to the production area, push it to a PostgreSQL database, and the same for the model, right? So a lot of manual labor. And their main objectives was to streamline this entire ETL pipeline. Also, they wanted to have the ability to compare different versions of the data set, and generally speaking, have an easy way to work with their data pipeline. So, starting from the beginning, they had this initial pipeline. First, we started by replacing the min.io service by an SOS database. Couple of notes about that. Their data set was stored in different directories, although each one of those directories was actually a different iteration of the data set. So when pushing it to SOS, we stacked that as different versions of the same data set. This is more or less a trivial operation, but it gave them access to configuration management. So now suddenly it was very easy for users to deploy a specific version of the data set. Different users can work on different versions of the artifacts, and you can easily swap in place the version of the data set that you are using. And then you can also tap into other more advanced features like the ability to diff different versions of the data set. You can easily spot which files have changed, which files were added, which files were removed. So back to the pipeline. We also automated the ingestion logic. So now we had an automation that would consume the raw data and push it into SOS. The whole vectorization nonsense was also converted into an automation, right? So now whenever a new iteration of the dataset was pushed into SOS, would automatically trigger the extraction of the embeddings, and those embeddings were consumed back into SOS, and you'd have this connection between the raw data and the embedding representation. The models were also being versions, well, different iterations of the models were also in the data set, and on the deployment side, we had a work area that was updating automatically when changes were pushed, deploying the vectors into the PostgreSQL database, deploying the model into the RAG service. So basically, the user only had to trigger the initial ingestion, and everything downstream was happening automatically. This end-to-end lifecycle management is quite valuable because now they had the ability to also reproduce past experiments, right? They had the history and the different versions of the models, different versions of the embeddings, of the ingestion logic, of the vectorization scriptware, so they can easily understand, for example, that version 4 of the model was created out of version 4 of the raw data, so on and so forth. Their key return on investment was that the pipeline lifecycle was reduced by 98%, right? So what was previously taking like a month or so was taking a couple of days. They also had the ability to build in tracking and diffing of data sets. The human intervention was only needed at the beginning, and everything else was happening automatically. And they had complete visibility over the data to model lineage. And because we are hitting the 16 minutes, let's call it a day. Do you have any questions? Please.
So the question is, what differentiates this from using like just a hyperscale cloud provider?
The domain knowledge, right? So our data management software has insight onto the type of data that we manage on the day-to-day. So I'm talking about cell views, about the libraries, the open access formats. So we have domain knowledge, which allows us to manage that data more efficiently, right? It's not a generic MLOps pipeline. It's a domain-specific pipeline for hardware design data management.
We had a question over here. Yes, sir? with all the different versions of data you have floating around, how do you know which one is the correct version? That is an excellent question.
That is an excellent question, actually. I have a slide just for that. But it's all about methodology, right? So there are different ways to work on your projects. You can either consider that whatever is the latest version available is the one that you should be using. But typically what you see in the industry is that there's a process to this, and you have, for example, a tagging methodology in which at every milestone that you achieve, you would tag your data. So then this is something that obviously needs to be discussed before the project starts. But you, for example, let's say that you are, I don't know, an ML architect and you want to put together the entire infrastructure. You know that you're only coming into play whenever your data has been tagged with some label that says ready. Okay, so only when your data achieves that milestone will it come into play. So it's all about the methodology that you adopt. We have a lot of, good question, we have a lot of granularity with respect to access control. So first of all, there are many different ways for you to enforce restrictions of access. We have role-based access controls. You have, you know, the ability to filter based on geography, based on a number of different criteria. The dynamic part there, for example, that's why I asked you to elaborate, right? I wasn't sure if you were thinking about, for example, something like an Active Directory or something that is running in the background, and you update the Active Directory and it repercutes itself automatically in SOS. So that level of live dynamic update doesn't happen by default, right? So these layers of access controls exist specifically for SOS, so they don't interfere with your operating system level permissions. And if, for example, you have an identity service that keeps track of that, we can ingest it as well, but it doesn't happen live, right? So there's like a, let's say, a periodic update of those permissions.
Great.
Yeah.